optimized pivoting blade, and superchannel thrust. Let's analyze the movements a diver makes when finning. The movements of the foot in relation to the leg are limited by the ankle's angle of mobility. The foot cannot incline beyond a certain angle. We'll place a classic fin on a virtual foot and analyze the components of the flow of water moving in the direction of the diver's motion. We can see that during the downward phase, there is a significant element that moves away from the direction of motion. This means that during this finning phase, the action tends to slow the forward thrust. MARES has introduced a system that makes it possible to constantly maintain positive thrust during all phases of the finning motion. This system is called Optimized Pivoting Blade, that is, the optimal tilt to the blade. During the finning phases, the area of the blade that is actively involved in the thrust can oscillate with well-defined angles in order to maximize thrust despite the limitation imposed by the ankle's movement. The optimized use of materials with specific elastic details and the computerized study of thicknesses and profiles allows for dynamic but fluid movements of the blade. The use of different materials and the special ribbing of the blade itself also creates a decidedly superior channeling effect. Studying how far Mother Nature has progressed in many marine mammals, MARES applied her principles to its fins. This led to the invention of superchannel thrust, a system that directs a greater amount of water in the direction the diver is swimming, preventing the dispersion of fluid streams in directions that aren't optimal to progress. The resulting advantage is improved thrust with less effort.